Let's talk about the myth of programming languages. So most people think that you can just like read one coding book and just learn one language, and that's going to be like a huge accomplishment, and you're going to know everything you need to know about coding, and you can go get a six-figure job as a software developer. And I'm here to explain why that's a myth. So, as I said, when most people believe you just have to learn one language. And when you first see code, it kind of seems like these lines of code are kind of just like like spreadsheet formulas. So maybe it's just like spreadsheet formulas on steroids. It allows you to do more complicated formulas. You can name variables instead of referring to cell A1 and so on. And so it kind of seems like if you want to make your own application, that you just have to find the right formula, right? You just have to like look up in the documentation, um, what's the pre-made formula that's going to do what I want the app to do. And another part of it is that people think you just have to type really carefully, right? Make sure there's no typos in these formulas that you're looking up. And yeah, you do have to type carefully, but you're going to find out it takes a lot more than that. So this myth of high-level languages, it started in the 1970s, and so any of the programming languages that you hear about being used today, like C Sharp, Python, JavaScript, those are all high-level languages. And these first became popular in the 70s with C, and a lot of people thought that means that coding is easy now, that basically anyone could do coding if they have a high level language, compared to what they were using before were called assembly languages. And a lot of people thought that these modern high level languages are much more, are so easy that basically anyone can do coding and it's not going to be a high paying job anymore. Well, that still hasn't happened yet. It's still very few people who can do it, and it's still not an average paying job. And the reason why is because you really need to learn assembly programming if you really want to know what you're doing. Things like, what are function calls? See, these spreadsheet formulas I've been saying, see, the reason why they're not really just spreadsheet formulas is because they're not. They're function calls. They're something much larger than that. It is related to the mathematical concept of a function call. What are parameters? How is recursion implemented? You know, it's ridiculous that people actually teach recursion to first year computer science students, expecting them that they're going to understand that difficult of a topic. Not only is the difficulty level ridiculous that it's taught way too early, on top of that, they're only teaching it to you using high level languages, and it is actually impossible to understand how recursive functions work by only looking at the high level languages. The people who say they understand it must have a very superficial understanding of it. Because until you've seen how a recursive call is implemented in assembly language, you don't understand it, and once you see how it's implemented, you're going to be pissed at that it's so simple, and the professors are basically just hiding this information from you because they believe in this myth of high level languages that was started in the 1970s. And this stuff I'm talking about is not just background information. It does matter for like security bugs, like buffer overruns. If you've never seen a function call in assembly, you don't know what a buffer overrun is, you don't know what the return address is, you probably don't know how to prevent a buffer overrun in production. And this is something that can cause people to be able to hack into your website. So, I mean, yeah, you can just follow the latest security guidelines that you read on some blog, but if you don't understand the concepts, there's no way that's going to be as good as actually understanding the concepts. So, you really need computer literacy. You need to know a lot about computers before you start studying computer science, right? It's not all about studying textbooks, right? I once told someone that the average computer scientist has spent more time studying textbooks than they have sitting at a computer. And it's really true. Um, People think it's all about scoring an A in math and like memorizing these formulas or something. That's not what it's about at all. You need to just get a lot of practice at using a computer. Stuff like being able to use the command line, being able to browse for folders, or knowing what file formats are, like PNG versus bitmap. Um, those are all things that you really should know before you start coding. Because the work that programmers do, it might be stuff like converting from PNG to bitmap, or making an app that copies from one folder to another, or even making an app that runs a command line program. Those are all things that I've had to do as a developer. And if you're someone who doesn't have much practice at using a computer and you don't even know what these things are, I just don't see how you're going to make the application, right? Another common piece of computer literacy that a lot of developers are missing is what is RAM and what is storage space, right? I actually had a computer science teacher who didn't understand the difference between these things. And he actually claimed that if we accidentally code a memory leak into our application, that we're damaging school property. Because he honestly believed that a memory leak takes up hard drive space and that it's permanent and there's no way to get it back. Like not even reformatting or low level formatting. Like it's gone, dude. It's gone. He actually believed that, dude. He actually believed that not only as an adult, but as the computer science teacher, he actually believed that. And another one is you need to know what a computer network is. You need to know what the internet is. I actually had a developer ask me, why is it slower to load from a web service compared to like adding two numbers together? So he had no idea that the code he's typing, it's telling the computer to like send a message over a network cable. Then that message is going to get copied to many different computers within the network, possibly on the internet. Then the return message is going to go through all those computers, all those long network cables. These could be going underneath the Atlantic Ocean across to America and back to Europe or something. And he's asking me, why is that slower than just adding two numbers together? These are basic concepts that you need to understand before you start coding. So the only way that you're going to learn this material is if you develop a new perspective. You need to be an application developer, not a computer scientist. Yes, it's important to understand computer science, but it's only background information. And we're here on LinkedIn, we're concerned about actually doing work and not just learning concepts, right? It's not about studying textbooks, it's not about scoring an A in math. Those are only the background concepts, but you need to know how to apply them. How do you apply computer science to application development? You need to first be a person who knows a lot about computers, who has spent a lot of time at the computer. And then you will know, how do you apply computer science to application development? And then you become a person who's not just guessing and they're feeling sorry for themselves because they think their job is so hard because you gotta guess at the right formula to use. No, that's not what it's about. It's you gotta identify as the person who's controlling the computer. That you're controlling the circuit boards inside the computer, and you're telling the computer, when do I send data over the bus to memory, or over the I/O bus to the hard drive, stuff like that. And then you're the one in charge. You're taking a more proactive approach, that you can tell the computer to do anything that's Turing complete, and you're not at the whim and mercy of whoever wrote the standard library. And if something's not included in the standard library, you're not just telling your boss it's impossible, right? That's not what computer science is about. It's about identifying as the person who is in control of the computer and they know a lot about computers, and they know computer science.